graph, right? We learned that the vertex form, or the vertex of an absolute value function, is the opposite of what's added or subtracted on the inside, right? Because it's x minus h, so h is positive 3, even though it looks like negative 3. But the k is exactly what it looks like. So the k is 1. Okay, so your first point should be x is 3, y is 1, so that's right here. And then the a value is the number in front that multiplies it. Sorry. Okay, so for this problem, a is 2, or in fraction form, 2 over 1. And that's useful for getting the slope to the right. It's rise over 1, so it means 2 up for every 1 right. Okay, so from that vertex, you go 2 up, 1 right. For the next point, 2 up, 1 right. Okay, and then going the other way, sometimes, what you're used to going like this because you're making a straight line for linear functions. But you need to remember for absolute value functions, the graph should be a V shape, the letter V. So you would instead go 2 up, 1 left, and 2 up, 1 left. Okay, so we do want to put arrows on both ends, right? Just like with pretty much all our graphs. Okay, and then I asked you to solve an equation. Okay, so the steps we learned yesterday was first you want to get rid of anything on the outside of the absolute value symbols. So you don't really want to try to get rid of the 2 right away, because if you divide by 2, this is going to turn into a decimal. Okay, and you cannot undo the minus 3 right away because it's protected by the absolute value. So your first action should be to get rid of the plus 1. Okay, so the opposite of adding 1 is subtracting 1. And you always do an equal action to both sides of an equal sign. Okay, so 2 absolute value x minus 3 equals 4. Okay, now is a good time to get rid of the 2. The 2 is touching the absolute value, which means multiplication. So to undo multiplying by 2, you would divide by 2. Okay, and now we have the absolute value by itself. There's nothing in front of it. There's nothing behind it. Okay, so remember, this is where we split it into 2 new equations. The inside could turn into positive 2 already, right? If the inside turns into positive 2, then absolute value of 2 is indeed 2. But another way we can do this is if the inside turns into negative 2, because absolute value of negative 2 would switch to positive 2. Okay, so again, at this step, the absolute value symbols go away. They get used up when you split it into 2 new problems. All right, so over here, now you want to get the x by itself. So to undo the minus 3, you add 3 to both sides of the equal sign. And then over here, again, to undo the minus 3, you would add 3 to both sides of the equal sign. Okay, so I have 2 answers, but let's make sure they're correct. Take what you think is the answer, plug it back into the problem, and see if the 2 sides are equal. Okay, so we do inside the symbols first. Absolute value of positive 2 is still positive 2, but now it's parentheses. 2 times 2 is 4. 4 plus 1 is 5. Okay, same number on both sides means the check is correct. Let's check the other answer as well. Okay, so is 1 a correct answer? Again, you do what's inside the absolute value symbols first. Now you do absolute value of negative 2. Negative 2 is 2 steps away from 0. So absolute value of negative 2 switches to parentheses positive 2. 2 times 2 is 4. 4 plus 1 is 5. Okay, so both answers work. So they are both correct. Okay. So some of you might have noticed that the 2 warm-up problems were very similar, right? They both involve to absolute value x minus 3 and then plus 1 at the end. So that was on purpose, right? So when we ask where is this function equal to 5, okay, so you go to 5 as the y, and you see it happens at 2 points, right? It happens here and here. And the x values are 1 and 5, which were the answers that we got over here. Okay, so again, hopefully it makes sense the reason that we have two answers, right? There's two different points on the V-shaped graph that have the same height, that have the same y value of 5. Okay. So again, we're going to build on these skills today. Do we have questions on any of this? Okay, so today we're going to continue working with absolute value, but instead of just doing equations, which means they have an equal sign, we'll be working with inequalities. Okay, so inequalities are, these symbols, right? Greater than or equal to, less than, or equal to, less than. Right, so with these symbols, the answer will be different, right? Because instead of simply equaling a number, you want to know where is it bigger than the number or where is it less than the number. Okay, but the good news is most of the steps are going to be the exact same as what we've been doing. Okay, so when your problem has an inequality symbol for absolute values, here's the strategy. Step one. Okay, so even though it's not an equation, even though there's no equal sign, you're going to just temporarily treat it as an equation. Okay, so you're going to solve for what we'll call the two key values. Okay, so in the previous warm-up example, the two key values were 5 and 1. Okay, it'll change from problem to problem. Okay, but you'll start by doing exactly what you did for that last warm-up problem. You'll do inverse operations until you've gotten x equals two numbers. Okay, so second step. You're going to use those two key values along with the direction of opening. To draw a sketch. Okay, so the way you know the direction of opening is the same as for quadratics. If A is any positive number, whether it's positive invisible 1, positive 5, positive 0.5, the graph will open upwards. If A is any negative number, then A will be upside down. The graph will be pointing downwards. Okay, and then the last step. Okay, so now we need to account for the fact that even though we temporarily pretended it's an equation, it's not actually an equation, right? It's one of these symbols. Okay, so you use the inequality symbol. To determine whether to shade above or below the line. Okay, so again, step one is going to be basically do what we did yesterday, last class. And then there's just a couple very short steps afterwards. Okay, so yeah, the good news is the vast majority of the work will be what you've already been practicing. Okay, but let's go ahead and go through an example or two together. Okay, so looking at the left problem, for what value or values of x is to absolute value x minus 1 minus 4 greater than 16? Okay, so step one, we temporarily pretend that instead of, the inequality symbol, it was just an equal sign. Okay, so just copy everything down, but replace the symbol with an equal sign. Okay, so now it's exactly like the warm-up problem, or now it's exactly like the problems from yesterday. Okay, so we want to get the x by itself, but first we got to get the entire absolute value by itself. So we need to get rid of these things on the outside. I'll undo the minus 4 first by adding 4 on each side of the equal sign. Now to get rid of the 2 that's multiplying, we can divide both sides by 2. And now that we have the absolute value by itself, nothing in front, nothing behind, this is where we split it up. The inside could equal 10 already, or the inside could equal negative 10, and the absolute value would allow us to switch it to positive 10. Yeah, very good. As Eden said, to get the x by itself, we need to undo the 1 that is getting subtracted. So the inverse operation of subtraction is addition. Okay, so we would add 1 to both sides of the equal sign. So our first answer is x equals 11. Our second answer, x equals negative 9. Okay, so if the original problem had been this equation for me in red, we would be done right here. Our final answer would be x equals 11 and then x equals negative 9, and we'd be done. Okay, but because the original problem was an inequality and not an equal sign, we have 2 more short steps to do. Okay, so if we reread the second step, we're going to use those 2 key values, 11 and negative 9, along with the direction of opening. Okay, so we need to know what direction this graph opens. Okay, so that is the A value, right? We learned last unit that, for example, x squared looks like this, but negative x squared looks like this, right? Whether that first number is positive or negative flips it upside down. Yeah, so it's the exact same for quadratics. Okay, so for this problem, if we look back over here, the number in front of the absolute value that's multiplying it is 2. Okay, so for this problem, A is 2, which is positive. So that means the graph opens up, which means that it's going to be a normal looking V, not an upside down V. Okay, so we're going to go ahead and draw our sketch now. Okay, so your sketch always starts with a horizontal number line. The good news is you don't need to mark a bunch of numbers. You don't need to go 0, 1, 2, 3, 4, 5, 6, 7, and so on. The only 2 numbers you need to mark are the 2 key values you got from earlier. Now, it is important that you put the order, or you put it in the correct order. Right, so remember, the smaller numbers always come first. So negative 9 should be on the left, and positive 11 should be on the right. Just like on a normal number line, bigger numbers to the right, smaller numbers to the left. Okay, so now we know that absolute value graphs look like this. They look like the letter V. But from the first step, we know that the two sides of the V will go through these two numbers. Okay, but there's two ways I could draw the letter V that goes through these two numbers. I could draw it like this, or I could draw it like this. Right, so this is where the A value comes in. For this problem, A is positive 2, which means that we want not the upside down V, we want the right side up letter V. Okay, so yeah, go ahead and draw a letter V that is the right side up, and that also goes through the two key numbers. Okay, so before we continue, this first new step of drawing a little sketch, are there any questions about any part of it? Like where the two numbers came from or why the graph is drawn the way it is? Okay, so last step then, use the inequality symbol to determine whether to shade above or below the line. Okay, so remember, up until right now, we've been pretending that it was just an equal sign, right? But the original problem was not an equal sign. So we need to use the actual symbol. Okay, so what information does this symbol give us? Okay, so I'll write it over here. Okay, so again, we know that inequalities have a big side and a small side. For this problem, the big side is facing the variable x. Okay, so what that means is we want x to be bigger than the other numbers. Okay, so in words, how I'll say this. Okay, so whenever the big side of the symbol faces the x in the problem, again, big side faces the x, that means that we want x to be bigger. So that means bigger is above. So we're going to shade the part of the graph that's above the line. Okay, so for this sketch, right, here's the whole thing. We only want the parts that are above the line. Okay, so starting over here, right, this is above the line, still above, still above, still above. Okay, we don't want to shade this part. This part is below the line, right? So don't do this. But then over here, we are again above the line. Okay, so for me, I highlighted in yellow. You can, like sort of shade in with like, or like redraw the on your papers. But yeah, this part is above the horizontal line. And this part is also above the horizontal line. Okay, so don't draw this, but just pretend for a second that the symbol was the opposite from the very beginning. Pretend that in the original problem, the symbol faced this way. Then the small end faces the x, so then we would have shaded below. Okay, so again, big end faces the x, shade above. Small end faces the x, shade below. For this problem, big end faces, so we shade above. Okay, so let me put this shading back. Okay, and from here, we are going to do the same interval notation that we did last unit. We want to state for which x values we shaded the graph. Okay, so this shading goes forever. Yes, the y values are going up, but we want to list the x values. The x values are going towards negative infinity. Okay, so this section goes from negative infinity up to negative 9. Okay, so negative infinity comma negative 9. Good question. Dominic asked, do we use brackets or parentheses? So we need to look back at the symbol one more time. There's a difference between just greater than and greater than or equal to with the underline. If the symbol has the or equal to, you would use brackets. But this symbol does not have the or equal to, so we will use parentheses. So I'll add that to the previous statement. Okay, so again, if we pretend for just a second that the original problem did have the underline like this, then we would have used brackets on the -9. Okay, but because the original problem did not have the brackets, we use parentheses instead. Okay, and we're going to do the exact same thing on the other side. This section is not highlighted, so we skip it. But then we have a second section over here. Okay, so remember we draw the floating U, the union symbol. This section starts at +11. And it goes forever to the right, which is approaching positive infinity. Okay, so you can still check your answer for inequalities, but you don't want to choose the numbers themselves this time. You want to choose numbers that are between the two numbers listed, right? So -infinity, -9 includes all the numbers between -infinity and -9. Okay, so again, you don't want to use the number itself because it's an inequality. You want to choose some number between those. Okay, so you could do -50, -15, -10, -9.01. I'll just do -10, right? If it's true that the answer is any number between -infinity and -9, then -10 should work. Okay, so you want to go all the way back to the first step, the beginning problem, and try plugging your number into there. So x is now -10. Okay, and notice I'm going back to the inequality step, not the equal sign step. Okay, so again, I've substituted in -10 in for x. -10 minus another 1 goes even more negative to -11. Absolute value of -11 is +11. 2 times 11 is 22. 22 minus 4 is 18. Okay, and now you check, is this a true statement? Yes, the bigger end of the symbol is facing the bigger number. So this is true. Okay, and you could do the same thing for 11 comma infinity. You could pick any number between 11 and infinity. You could do 12, you could do 15, you could do 1 million, any number between 11 and infinity. All right, so any questions on this first one? Okay, let's try another one together. So over here, for what value or values of x is -3 absolute value x plus 7 greater than or equal to -2. Okay, so we want to, again, first step, pretend it's an equation. Okay, so turn that symbol for now into a regular equal sign. And get your two key values the same way we've been doing the past day and a half. Yeah, so again, you don't want to divide by -3 right away because this would turn into a fraction. So let's start by getting rid of the -7. Oh, sorry, get rid of the +7 by doing the inverse, which is -7. Okay, so remember, this is not subtracting 3. This is a -3 that is touching the absolute value, so it's currently multiplying. So the opposite of multiplying by -3 is dividing by -3. Okay, so absolute value of x equals 3. That means the inside x itself could be 3, or the inside x could be -3, and the absolute value would switch it to +3. Okay, so again, when you split it into the two new equations, the absolute value goes away. It gets used up. Okay, so the two key values for this problem are 3 and -3. Okay, so step 1 is done. We've got our two key values, 3 and -3. Next, we're going to look at the direction of opening. So for this problem, A is -3. All right, the number that multiplies the absolute value is -3. Okay, so since A is negative, that means that the graph opens downward. Okay, so when we draw our sketch, the V will be upside down. Okay, so the sketch, again, always starts with a horizontal line. Your two key values from step 1 need to be marked. Okay. And think to yourself for a second, how are we going to draw the graph in? Okay, so yeah, exactly. It's not going to be like the previous problem because A is now negative. So you need to draw an upside down V that goes through the two key numbers. Okay, so it'll look something like this. Okay, so now you move on to step 3. Use the inequality symbol to determine whether to shade above or below. Okay, so you look at the symbol, you look at the location of the x. For this problem, the big end is facing the x. Okay, so that means that we shade above again. If the symbol had been like this, if the small end faced the x, then we would shade below. The underline tells you whether to use parentheses or brackets. Exactly. Yeah. So let me just recap again. So the big end faces the x. That tells you to shade above. Okay, so looking at your sketch, you do not want to shade right here where I'm currently highlighting because this is below, right? So the parts that are above the line are from here all the way to here. Okay, so hopefully you can see I just highlighted it in yellow. All right, this section is above the horizontal line. Okay, so this time it's all one connected section. It's not two separate sections. So the shaded section begins at -3 and it ends at +3. Okay, so there's no infinity, there's no union. Why what? Well, so because the graph is upside down, right? When we look at this dividing line, this part is above, right? So this is all one connected section. When the graph was pointing the other way, right, there were two different sections that were above the line. But when the V is flipped upside down, now only like the little triangle top is above. Yep. So again, this section above the line starts at the x value of -3, and it continues until the x value of +3. Okay. Yeah, so you list the starting x value, comma, the ending x value. Okay. And then as Eden said earlier, because this symbol has the or equal to, that means we use brackets. Okay. So again, we can check by picking any number between -3 and 3. Okay. So I'm just going to check 0, right? 0 is between -3 and 3. Okay, so I go all the way back to the beginning and I replace x with 0. And I want to see if this becomes a true statement. Absolute value of 0 is still 0. -3 times 0, anything times 0 is still 0. 0 plus 7 is 7. And 7 is greater than -2. Okay, so that works. Okay, so again, it's really mostly the same steps we did yesterday and in the warm-up, right? There's just two very short steps, right? You draw a little sketch, and then you write your answer in interval notation. You're talking about this part? It depends on whether there's one section shaded or two. You see here, the two highlighted sections don't touch each other, right? There's a big gap in the middle. So this section is here and this section is here. We need two different answers because there's two disconnected sections. For the second problem, this highlighted section is all one connected piece, right? There's no like gap right here. It just goes straight from here to here. So that's why you write it with a single comma, not two. Okay. All right. Any other questions on the warm-up? Okay, let's go ahead and have everyone practice it then. So please turn to the second page. Okay, so yeah, let's go over a special situation. Okay, so here is an absolute value graph, right? We have seen many that look like this before. Okay, let's go ahead and answer these three questions on the right. Okay, so first question, for this graph over here, for which values of x does f of x equal 5? Okay, so we remember that this means that we want y to equal 5. So we look at the graph, and the graph never crosses 5, right? These arrows point downward, they don't point upward. So no matter where you go on the graph, you'll never get to 5. Okay, so is none. There is no x value that hits that y value. Okay, now we have a second question here. Now we want to know for which values of x is f of x greater than 5, right? So again, now we want the y values to be bigger than 5. Well, yeah, we don't even hit 5 exactly. There's no way we could get above 5. So there's also no x values for that. Yeah. None, because 0 would mean something else. 0 would mean it hits, yeah. Okay, and now the last question though, at what value or values of x is f of x less than 5? So where is the graph below 5? Well, everywhere, right? The entire graph is below 5. Yeah, it's kind of messy looking, sorry. But yeah, the whole thing. Okay, so no matter how far left you go, no matter how far right you go, right? The entire graph from x is negative infinity to x is positive infinity is all below 5. Okay, so we saw, those of you who completed the homework, you saw one example of this, right? Sometimes an equation, an absolute value equation has no answer. Okay, so in what situations does that occur? Let's go ahead and write this down. If an absolute value equation has the absolute value with nothing outside, meaning you've already moved over or canceled out anything that was outside. If the absolute value equals a negative, there is no solution. Okay, because the definition of absolute value is the distance from 0. So if you have a distance equal to a negative number, that is impossible, right? We do not consider distances to ever be negative. Okay, so again, if there's an equal sign and the absolute value by itself equals a negative, there's no solution. Okay, so we'll come back to this next part, but let's jump down to the examples below. Okay, so right now it does not equal a negative. So it seems like everything is fine, but the 7 is on the outside. We need to get rid of that. So when we subtract 7 from both sides, now the absolute value equals a negative. Okay, again, this is impossible. No matter what is on the inside, if you have an absolute value equal to a negative, there is no solution. Okay, so again, it doesn't matter if it's -2, -5, -1, -1,000,000. If it equals any negative number, there's no solution. Distance can never be negative. Okay, but we want to be careful because if we look at problem 2 over here, now we might say, oh, it equals a negative, right? It equals -1. That means there's no solution. You don't check until the absolute value is by itself. Okay, because once you undo the -9, now the other side is positive, which is okay. Distance can be positive. So this one will have solutions, right? The inside could equal 8 directly, or the inside could equal the opposite, -8. Okay, so again, don't check for the negative on the other side until the absolute value is by itself, meaning nothing in front and nothing behind. Okay, so that's the equation part. So lastly, what if you have an absolute value inequality? Okay, so same start, right? If it has the absolute value with nothing outside, and a negative on the other side, okay, I'm just gonna make things easy actually. Okay, so as we saw in the graph above, right, depending on what direction you go, your inequality could either completely miss the graph and there's no solution, or you could shade in the entire graph and the answer is negative infinity, comma, infinity. Okay. So the easiest way to tell whether it's no solution or negative infinity, comma, positive infinity is you try an easy number. Usually 0 is very easy. If it's true, then the answer can't be none because you already found an answer. So then it'll be negative infinity, infinity. Okay, so let's go ahead and try applying this to problem 3. So as always, with inequality, we temporarily pretend it's an equal sign. We want to get the absolute value by itself. So to undo the 3 in front, we divide both sides by 3. Okay, and so at this point, the absolute value is by itself, and it equals a negative. Okay, if the original problem had been an equation, we would just say no solution and we would be done. But because the original problem was an inequality, we need to try a number. Okay, so again, if your two options are no answer or every number from negative infinity to infinity, you just need to check if one number works, right? If this number works, the answer can't be none, then it must be everything. Okay, so we're going to go back to the original problem and try plugging in 0. So I replaced the x with 0. You do the inside first. 0 plus 1 is 1. Absolute value of 1 is still 1. 3 times 1 is 3. Okay, and then now you decide, is this a true statement? Yes, the big end is facing the bigger number, right? Positives are bigger than negatives. Okay, so if you get a true statement, that means that all numbers will work, not just 0. Okay, so let me show you the last possibility. Okay, so to get rid of the negative, you can divide both sides by -1. Okay, so again, we get the absolute value by itself equals a negative number. But because it's an inequality, we need to try a number. Okay, so go back to the original problem, plug in 0 for x. Okay. Absolute value of 5 is still 5. You stick on the negative sign from the outside to make it -5. -5 minus 6 is -11. Okay, and this is a false statement, right? -11 is not greater than +4. So if the number you try doesn't work, that means there is no solution. Okay, so remember, you don't need to do this for every single problem, only if the absolute value by itself equals a negative. Okay, if it equals a positive, if it equals 0, then great. You just draw the sketch like normal. Only in this rare situation that it equals a negative. Sure. Okay, so the last page of the handout will be your homework. Okay, like always, make sure you try it first, self-grade using the answer key, and then upload the finished version to Canvas.